Hello everyone. I am making this video to have this worksheet solved. We have a worksheet and that worksheet may have some difficulties. Some people have some doubts. So let's just make sure that we all resolve the doubts. All the doubts are cleared, and that's why I am making this video. So this one video will take care of all the doubts. So let's just, without wasting any time, just start with the worksheet. There are 10 multiple choice questions in the worksheet. So the first one is, what is the next number in the given sequence? 1, 4, 9, 16. If you observe carefully, this sequence is a square sequence. The first number is 1, which is 1 into 1, 1 square. The second number is 4, which is 2 into 2, 2 square. 3 into 3 is 9, which is 3 square. 4 into 4, 4 square will be 16. So the next number will be 5 into 5, that is 5 square, which will be equal to 25. So the answer is B, 25. Which of the following sequence represents the even numbers? It is very simple. 2, 4, 6, 8, 10. The answer is B. What is the next number in the sequence? 1, 2, 4, 8, 16. If you observe carefully, every next number is double of the previous number. This sequence is a power of 2. This sequence can be called as a sequence of power of 2. So this is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4 and so on. But the next number is equal to double of the previous number. So 1 ka double 2, 2's double is 4, 4's double is 8, 8's double is 16, 16's double is 32. That will be the answer, 32. Let's see the question number 4 now. In the sequence 1, 3, 6, 10, 15, what is the next number? If you observe this sequence, the sequence is the gap between these two is 2. Then the gap is 3. Then the gap is 4. Then the gap is 5. So the next gap will be 6. So the next number will be 15 plus 6, which is 21. This is a special kind of sequence. We'll talk about this as well. I think there is one more question on this kind of sequence. But let's just see that. The sequence starts with 1 and the first gap is of 2. Then the next gap will be of 3. Then the next gap is 4. So the difference between the two numbers, the difference is increasing by 1. The difference is not constant. The difference is increasing by 1. So this is, the difference is 2. The next difference is 3. The next difference is 4. The next difference is 5. Next difference will be 6. So 15 plus 6 is 21. A is the answer. Which number is a triangular number? This is 10. You can make the triangular, dots, connect, make those triangles out of dots. You will find out that there are 10 dots. Out of these numbers, only 10 is a triangular number. The figure formed by connecting all the points to each other via straight lines is called as. Let's just see this. Suppose we have this point. Suppose we have this point, this point, this point, and this point. Only 4 points. So we connect these two, we connect these two, and these two. This is called as polygon. But we are talking about all the points, the figure formed by connecting all the points to each other. So this point is not only connected to this or this, it is also connected to this. This is also connected to this. So every point is connected to everything. That is called as complete graph. B is the answer. If every point is connected to every other point, then the figure so obtained is called as complete graph. So the answer is B. Next question. How many sides does a nonagon have? Pentagon has 5 sides, hexagon has 6 sides, heptagon, or it is also sometimes called as septagons, have 7 sides, octagon will have 8 sides, and nonagon will have 9 sides. So the answer is C, 9. Next question 8. The number of dots forming a square of side 5. How do you, what is this? This is what is meant by the question. If you want to form a square by having dots, and the only way it can happen is you have as many dots on the horizontal side and the same number of dots are there in the vertical side. So along the row and along the column, the equal number of dots are there. So this kind of arrangement will result in a square formation. And how many dots are there? 1, 2, 3, 4, 5. So this is each square, each side has 5 dots. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Total is 25. So the answer will be C, 25. Which of the following sequences show the power of 3? Power of 3 is A. This is not, there is no chance here. It is power of 2. This is a cube sequence. This is only even number. A is the power of 3. 1, then 1 is multiplied by 3. 3 is multiplied by 3. 9 is multiplied by 3. 27 is multiplied. Every number is multiplied by 3. This is power of 3. What is the next figure after a triangle, square, pentagon and hexagon in the sequence of regular polygons? If you go on making regular polygons, then you start with a triangle which is called as equilateral triangle, then you make a square, then you make a regular pentagon, then you can make a regular hexagon. What will be the next? It is called as heptagon, the regular heptagon. Heptagon has 7 sides. Sometimes it is also called as septagon. But the more popular name is heptagon. So the answer of 10 is B, heptagon. After heptagon you will get octagon, then nonagon and then decagon and so on. Okay, let's solve this question now. Extend the sequence 1, 2, right. Extend the sequence 1, 2, 4, 8, 16 by writing the next 3 terms. And what is the pattern rule? Sometimes it is called a general rule, sometimes it is called as pattern rule, sometimes it is called a sequence rule. They all mean the same. We want to identify by what logic every number is placed in that sequence. So we have to identify the logic here. First, what I will do, just be observe very carefully. This is one of the problems that I am solving. There can be others as well. Just observe this. It is not difficult. It is very simple. I will write n equal to 1, 2, 3, 4 and 5. Then we'll have 3 more numbers. So I am writing 6, 7 and 8. What is the logic behind this? How many numbers are there? 1, 2, 3, 4, 5 and then 3 next terms 6, 7, 8. This is only the count. There is nothing else. Only the count. First number, second number, third number, fourth number, fifth number and so on. So we'll write the numbers. First number is 1. Second number is 2. Third number is 4. Fifth number is 8. Fourth number is 8. Fifth number is 16. Very interesting. Now this is a sequence. And the sequence you can identify is power of 2. So every next number is equal to twice of the first number. 1 into 2 is 2. 2 into 2 is 4. 4 into 2 is 8. 8 into 2 is 16. So the next will be 16 into 2, which should be 32. 32 into 2 will be 64. And 64 into 2 will be 128. This is easy. Predicting the next number, if you identify the logic, then predicting the next number is easy. It is not that difficult. But we still have not found out the pattern rule or the general rule or the sequence rule. How do we find that? Please kindly pay attention to this. Now this 1 is equal to, let's not talk about this one. Let's start with 2. This 2 is equal to only 2. But this 4 is equal to 2 multiplied by 2. So you are multiplying 2 twice. This is 2 into 2 into 2. You are multiplying 2 3 times. This is written as 2 raised to 3, where 2 at the base is showing what is to be multiplied. And the number here, which is called as power or the index, this number is the count about how many times we multiplied. We multiplied once, we multiplied twice, we multiplied thrice. So this is 2 raised to 3. This is 2 raised to 2. This is 2 raised to 1 because we have not multiplied any further times. We have multiplied twice. This 16 is 2 into 2 into 2 into 2, which is equal to 2 raised to 4. 32 will be 2 raised to 5 and so on. Now if you observe carefully, what is happening here is, this is coming as 2 raised to 1, this is coming as 2 raised to 2, this is coming as 2 raised to 3, this is coming as 2 raised to 4. Now, after this, we'll try to map it with this number. यहाँ पे the base is same, 2, 2, 2, 2, everything base is same. This number 1 is less than 2 by 1. 2 minus 1 is 1. 3 minus 2 is 3 minus 1 is 2. 4 minus 1 is 3. 5 minus 1 is 4. So the basic pattern of this is 2 raised to a number which is 1 less than this number. So if this number is n, the answer is n minus 1. What I am saying is, whatever be this number, reduce 1, subtract 1 from it, and whatever number you get, that you get here. 2 raised to 1 is 2, 2 raised to 2 is 4. This 3 minus 1 has become 2. 4 minus 1 has become 3, so 2 raised to 3 is 8. 5 minus 1 has become 4, so 2 raised to 4 is 16, and so on. So this entire general rule is general rule or pattern rule or sequence rule. This is 2 raised to n minus 1. I hope you understand this. Let's start with the next problem. Write the next 3 odd numbers after 13. It's very simple. 15. Oh. 19. But the question can also be write the 4th odd number after 28. So you start with 28 and you want to write the 4th odd number. So 28 के बाद first odd number is 29 first, 31 is second, 33 is third, and 35 is 4th odd number. There can be questions, any kind of question can be framed with this, but this is very simple. Next question. Draw a picture showing 5 triangular numbers. I already made the picture, let's see this. Triangular number here would be 1, 3, 6, 10 and 15. If you remember that MCQ, I was telling you 10 out of the numbers were 7, 8, 10 and 12, and only 10 is a triangular number out of them. These are the triangular numbers. Right? Draw a picture showing 5 triangular numbers. One triangular number, second, third, fourth and fifth. We are showing 5 triangular numbers. Write the first 5 cube numbers. Square is multiplication of the same number twice. Cube is multiplication of the same number 3 times. Supposedly I am writing 5 into 5 into 5. This is called as 5 raised to 3 or 5 to the power of 3. और उसका मतलब होता है 5 cube. So the cube number is 5 raised to 3, which is 5 into 5 into 5, which will be equal to 125. So we are writing the first 5 cube numbers. The first cube number will be 1 cube, which is equal to 1 into 1 into 1 is 1. Then there is 2 cube, which is equal to 2 into 2 into 2, which is 8. 3 cube is equal to 3 into 3 into 3 is 27. 4 cube is equal to 4 into 4 into 4 is 64. And 5 cube is equal to 5 into 5 into 5 is 125. These are the cube numbers, the first cube numbers, first 5 cube numbers. Write the first 5 cube numbers. These are the answer. But if the question was write the sequence of first 5 cube numbers, then the sequence would be 1, 8, 27, 64, 125 and so on. This would be the sequence. We are not asked about the sequence, so this is good enough. If you ask me, I would advise you that after writing this, also write the sequence. The sequence of cube numbers is, and write this. It is always good, it is always better. Okay, next question. Find the sum of the first 5 odd numbers. What do you observe? This is very interesting. So we find the sum of first 5 odd numbers. What is the first odd number? 1 plus second odd number is 3 plus third odd number is 5 plus fourth odd number is 7 and the next odd number, fifth odd number is 9. And the sum is 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 7 is 16, 16 plus 9 is 25. The sum of first 5 odd numbers is equal to 5 into 5, 5 square. It's very interesting. First 5 odd numbers sum is 5 square. If you take only this, if you take only 1 plus 3 plus 5 plus 7, first 4 odd numbers only, first 4, sum of first 4 odd numbers. Let's see, 1 plus 3 is 4, 4 plus 5 9, 9 plus 7 16. This is 4 square. First 3 odd numbers, 1 plus 3 plus 5, 1 plus 3 is 4, 4 plus 5 is 9, this is 3 square. First 2 odd numbers, this is 2 square. And only one odd number, that is 1 square. So how many odd numbers did you have? You had 5 first odd numbers. So the answer will be 5 square. If you had first 4 odd numbers, the answer will be 4 square. Then if you take first 3 odd numbers, the answer will be 3 square. The sum of them. If you take first 2 odd numbers and add them, the answer will be 2 square, and so on. That is how this rule is, that is how this pattern is. It's a beautiful pattern. Next question. Find the next 3 numbers in the sequence 1, 2, 3, 5, 8. Which, if you identify which series is this, we'll talk about this. Let's see what is this series like. First is 1, then 2, then we get 3 because the addition is 3. 1 plus 2 is 3. Then 2 plus 3 is 5. Then 3 plus 5 is 8. 5 plus 8 is 13. And we want to write the next 3 numbers. So 8 plus 13 will be 21. 13 plus 21 will be 34. And 21 plus 34 will be 55. This is what we get as the next 3 numbers of this series. 1, 2, 3, 5, 8, 13. Every number is equal to sum of the previous 2 numbers. Every next number is equal to sum of the previous 2 numbers. So 3 is equal to 1 plus 2, 5 is equal to 2 plus 3, 8 is equal to 3 plus 5, 13 is equal to 5 plus 8. So the next number will be 8 plus 13 is 21. The next number will be 13 plus 21, 34. Next number will be 21 plus 34, 55, and so on. There is a special name for this series. What is the name for this series? Name is Virahanka series. We have it in the textbook. Okay, the next problem. Describe the pattern is in Coach Snowflake. Now, Coach Snowflake is, let's see this first. This is what the Coach Snowflake is. I have taken the screenshot from the textbook. You start with an equilateral triangle. All sides are equal in the triangle. After that, what you do is, you will modify this as follows. We only have to describe. We have to do nothing else. Only the description. So we'll do this. I'll draw this triangle. Equilateral triangle. Now I am dividing every side into three equal parts. One part, two, 1, 2, 3. This will also be divided into three equal. 1, 2, 3. 1, 2, and 3. Three equal parts. Please don't mind my drawing. My drawing is pretty poor. And not what we'll do is we'll keep this side and this side as it is. ये बीच में वाला गायब कर देंगे हम लोग और उसकी जगह ये बनेगा. यहाँ पे एक छोटा इक्विलेटरल ट्रायंगल डाल दो. Put a small equilateral triangle here. Put a small equilateral triangle here. And this line should be eliminated. So we'll try to eliminate this line. Not extremely effective, but still okay. So it looks like this. Now from this, every side, this has to be, even this side has to be divided into 3 and the middle part is gone and वहाँ पे एक triangle आ जाएगा. This will be the triangle. So effectively, this entire thing goes this line can be divided into 3 parts. This line divided into 3 parts. The middle part is 1. वहाँ पे एक triangle आ गया. That's the only thing. So you draw an equilateral triangle. First you start writing. We are describing the sequence. We are saying the first we'll start is equilateral triangle is a triangle in which all sides are equal. First draw an equilateral triangle. Then divide every side into 3 equal parts. Keep the 2 parts on the end as it is, and the middle part should be erased, and an equilateral triangle should be replacing that particular part. So this sides divided, this is divided, this side, this would be the side, and it is divided into 3 parts, 1, 2 and ये 3. 3 वाला चला गया, वहाँ पे एक triangle बन गया, and that's it, and you get this. There is nothing else. This kind of, we think it is a, basic or very rudimentary artistry, but in computer graphics there is a big topic called as Bezier curves, which actually derives from this. It's not same as this, but it takes a lot of knowledge from this kind of graph, this kind of snowflake. We will study that in the if you go to that level with computer graphics, you will study that. Otherwise, this is a good sequence to have. It's a good pattern to know. It's just the pattern that we want to describe. We described it. Next question. What pattern do you observe in adding consecutive odd numbers starting from 1? Illustrate with an example. We have seen this before. The question was in slightly different words, in different language, but we are basically what we are saying is, what pattern do you observe in adding consecutive odd numbers? So I take one odd number 1, next odd number will be 3, and you add them, you get 4, which is equal to 2 square. Okay, we are saying not 2 odd numbers, we are saying consecutive odd numbers, but 3 odd numbers. So we get 1, next odd number is 3, next odd number is 5. So we took first 3 odd numbers. Their addition is 9, which is equal to 3 square. Next odd number 1 plus 3 plus 5 plus 7. The addition is 16, which is equal to 4 square, and we had 4 odd numbers here. So the number of consecutive odd numbers we are taking starting from 1. The same number square you can obtain if you add them. That's the pattern. That's what we are talking about. What pattern do you observe in adding consecutive odd numbers starting from 1? When you add consecutive odd numbers starting from 1, you get the square of that number, which is equal to the count of the odd numbers that you took. Count the number of odd numbers that you are adding. The count ka square, the square of the count, is obtained as the sum. This is the pattern. The illustrated with an example, we have taken 3 examples here. Next, which number sequence is formed by adding up all ones sequence? One sequence is only 1, that's it. So in a sequence where there is no other number but 1, is called as ones sequence. And now you add up. You add the one sequence. So if you add only first two elements of the one sequence, this is one sequence. You add only two elements. So you first write only one element. Then you add the two elements, you get two. Then you add three elements, you get three. Then you add four elements, you get four. Then you add five elements, you get five. You add six elements, you get six. You add seven elements, you get seven. You basically are going to get natural numbers. That's all it is. If you get to solve it, is very simple. But just the words, if you see, the words which are written to describe the problem reads to be really difficult sometimes. But it is not difficult. It is only if you get to solve it, it is so simple. Because the problem is not difficult. The way the problem is written, that English construct is difficult sometimes. So it's very easy to handle. If you get into it, it's not difficult at all. Right, the first 5 terms we have written 7 terms. Draw and explain the sequence of regular polygons up to a decagon. I don't fancy this problem coming in any kind of examination because drawing regular polygon is a very difficult proposition. But I have generated the images and I am only sharing those images to you so that you know the answer. Write the first 5 terms. See this. Draw the regular images. Sorry. Draw and explain the sequence of regular polygons up to a decagon. See this. Triangle. Polygon starts with a triangle. Regular polygon is an equilateral triangle. Square, 4 sides. 5 sides, pentagon, regular pentagon. 6 sides, regular hexagon. 7 sides, regular septagon. 8 sides, regular octagon. I could not generate the nonagon and decagon. I am not asking you to draw this. You must know this. That's it. 21. Draw and label the sequence: triangle, square, pentagon, hexagon, heptagon, and mention the number of sides for each. I am drawing this. This is very similar to previous problem. Only I am drawing this. I am generating those images, and then we'll label them, and we'll also label with the number of sides. Triangle, square, pentagon, hexagon, and this is heptagon. Mention the number of sides. These sides are 3, 4, 5, 6, and 7. That is all that we need. I hope you understand this. We'll solve the next problem. Find the pattern when you add the sequence of hexagonal numbers. What is the hexagonal number? Let's see this. The hexagonal numbers are 1, 7, 19, 37. It's a very interesting pattern. See this. If you add only 1, so out of the given pattern of hexagonal numbers, you selected only 1. So the sum up to the first number is 1. Then you selected first 2 numbers. 1 plus 7 will be 8. Then you select first 3 numbers. So 1 plus 7 plus 19. 1 plus 7 is 8. 8 plus 19 is 27. And up to the fourth number, if you add 1 plus 7 is 8. 8 plus 19 is 27. And 27 plus 37 is 64. Up to the fourth number, this is a cubic sequence. All the numbers are cubes. This is 1 cube, this is 2 cube, 3 cube, 4 cube. Is the beauty of this. It's a very interesting problem. But it is valid up to the fourth number only, 37. The next number, if you take of this hexagonal sequence, then it does not follow the same pattern. That's why it is said up to 4 terms. It is saying up to 4 terms only, because it works only up to 4 terms. Beyond this, it does not. The addition is not a cube number after that. 23. Find the sum of first 10 odd numbers without actually adding them individually. You remember? If you add first 2 odd numbers, the answer is 2 square. If you add first 3 odd numbers, the answer is 3 square. If you add first 4 odd numbers, the answer is 4 square. If you add first 5 odd numbers, the answer is 5 square. If you add first 10 odd numbers, then I'll write this. I'll not add without actually adding it inside. So I'll not add. I'll only write 1 plus 3 plus 5 plus 7 plus 9. 5 odd numbers are there. Plus 11 plus 13 plus 15 plus 17 plus 19. And I am without even adding, I am writing 100 is the addition. Because I know the addition of first 10 odd numbers will be equal to 10 square, and 10 square is 10 into 10 is 100. This is based on the pattern. Answer is very simple. Next, which number sequence is obtained by counting the sides of regular polygon? List the names and sides up to 10. We are listing the names from triangle will start. So we are writing starting with 3. So if there is an equilateral triangle, the sequence is having 3. Square will have 4 sides. The number of sides we are talking about. Counting the number of sides of the regular polygon. Then we have 5 for pentagon, 6 for hexagon, 7 for heptagon, 8 for octagon, 9 for nonagon, and 10 for decagon, up to 10 sides. The names are given: triangle, equilateral triangle or triangle is square, pentagon, hexagon, heptagon, octagon, nonagon, decagon. The names are there, the number of sides are this. What kind of sequence is obtained? We get the natural numbers, only the first 2 natural numbers are missing. 1 and 2 are missing because there is no possibility of having 1 side or 2 sides in a polygon. Polygon is only possible with minimum 3 sides. Because polygon is a closed figure. One side, this is not closed. Even second side, this is not closed. This part is open. The closed figure can be formed by 3 sides or more sides. So polygon is not possible with 1 or 2 sides. That's why it is starting with 3. Last question, 25. Suppose you multiply each triangular number by 6 and then add 1. Write the first 3 terms and describe the new sequence. What are we supposed to do? We are supposed to take the triangular sequence. Alright, we have the triangular sequence. Then each number is multiplied by 6 and then 1 is to be added. So 1 is to be multiplied by 6, so 1 into 6 and then add 1. 2 is to be multiplied by 6 and then add 1. 3 is to be multiplied by 6 and then add 1. So this is 7, this is 13 and this is 19. Write the first 3 terms and describe the new sequence. The new sequence is 7, 3 and 19. Suppose you multiply each triangular number by 6 and add 1. Write the first 3 terms. Yeah, 7, 13 and 19. Good. Yeah, that's fine then. This number is a strange, this number maybe the question wasn't expecting this. But then this 7 and 19 are also a part of hexagonal series, a sequence of hexagonal numbers. But 13 is not there. But okay, I think this is fine. This is what we are asking, this is what we were asked. Every number must be multiplied by 6 and then 1 has to be added. We have done that. That's all we wanted. We got this. Describe the new sequence. The sequence is starting with 7, going up to 19 with a gap of 6 consistently. That's the description. Alright, you solved the first 25 questions, only 25 questions in the worksheet. I hope this was fine. I hope there is no problem left now. Should there be any doubt and difficulty, you can always contact me, you can always message me and ask me for whatever doubt you might have. This is, I think, comprehensive for this chapter. This covers the entire chapter, and should there be any problem, you can always reach out to me. We are having school tomorrow, so you should always be, feel free to ask the doubts. I hope this is good. I hope this works. Thank you so much.